Okay, we can get started and then I'll just kind of have people trickle in and whatnot because we're going to be offering like remote makeup of like live lectures more to come. But alrighty, welcome everybody in person. I'm very excited to be here. This is Bowen. I was on the Zoom 2 weeks ago, but now I'm here in person. I had to take an emergency trip home to see some family, but I'm back, super excited. Hopefully Arun was pretty good at explaining some of the concepts last week. And yeah, let's get started. So lecture 3, today we're going to be talking about security in the cloud. So it should be pretty exciting. And I'll try to keep it at a nice pace so you guys can follow along and ask questions. Cool. Alrighty. So our agenda, let me turn off all these. Our agenda today, security and compliance. We're going to be talking about the shared responsibility model in AWS. We're also going to be talking about some things and services like AWS Artifact and some support resources. So when you're actually using AWS, what support do you have when you're having trouble implementing things? We also have some security related services that we want to talk about. There's a whole list from Trusted Advisor all the way down to AWS Macie, which we'll get into, and then also some web security services. But these are some of the things we're going to be testing on. Some of them won't be tested on, but we'll just let you know which ones are. That way you can kind of prepare, and then hopefully we do a good job of that. So cool. Any questions so far? Perfect. Okay. Nice. So the AWS shared responsibility model. So this is one of the best parts about cloud computing, is that the idea of you don't have to do so much work in terms of compliance and security when you're using AWS. AWS handles a lot of security practices and a lot of compliance measures. And you as the customer, the only thing you need to do is make your applications successful on your own and make them secure. So the idea of security in the cloud, that's your responsibility. So that's making sure your EC2 instances, for example, are secure. That's not on AWS. AWS's responsibility is the security of the cloud. So they're making sure their data centers and hardware is working properly and that nothing's going to get impacted by that. So you can build that trust with AWS to make sure that you have the essentials to build a successful application. And in terms of who's in control of what resource, we talked about infrastructure as a service, platform as a service, and software as a service. Those kind of define the boundaries of who has control over what. So certified compliance. One of the big things about actually building applications in not just the cloud, but everywhere, is you need to have certified compliance, meaning you have to follow standards that are put in by law, by entities, to make sure things are secure and that everybody who's using your service is not going to get ripped off or exposed to any data leaks, things like that. So how do we know AWS is safe for those certain scenarios where we're worried about data leaks? Well, AWS has certifications in a lot of areas. They have a PCI DSS. I don't know the exact acronym, but these are certifications that kind of protect your data. And then HIPAA, I think that's something to do with health insurance. I forgot the last 3 letters, but it's health insurance. And it's just making sure like your health insurance information is secure and that not everybody has access to that. So AWS has those kinds of certifications to make sure that data is protected. And you can find documentation about those compliance certificates in something called AWS Artifact. That's really important. So when you're presenting about your application and you're saying you're using AWS, you have detailed documentation showing that AWS is doing the best job it can to protect on the cloud. Sounds good. And let's see here. Here's the link to get more compliance details. So how do we, as customers of AWS or builders of applications in AWS, stay compliant? Because AWS has all those certifications, but what do we need to do to make sure we're compliant? Well, there's 2 services that AWS actually offers. There's AWS License Manager, And this basically allows you to easily manage AWS software, like when you want to integrate some softwares from Microsoft, Adobe, etc. You need to have licenses for those things. And you want to make sure that your licenses don't expire, or when they do expire, they're renewed. Well, License Manager is a service in AWS that automatically does those things for you and makes sure all the software implementations in your applications are up to date and they don't violate any protocols. So License Manager in short terms means the ability to keep all your licenses in the same place and be able to keep track of them, because that's important. You want to be able to use companies' licenses without facing any legal troubles. And then there's AWS Certificate Manager. So in web apps and applications, websites need something called SSL and TLS certificates. This is TLS means transport layer security, I believe. And then SSL has the word socket in it, but that's not really relevant. All you need to know is that certificates in SSL and TLS are just validating the fact that your web application is secure when users connect to it, and they make sure that data is not compromised. And then Certificate Manager in AWS just manages the process of renewing that certificate and making sure the connectivity side of security is safe for you. Any questions? I went a little bit fast, so I'm gonna have to work on that pacing issue a little bit, but if you have any questions, feel free to let me know. Cool. Oh, yes, you have one? Oh, yeah. For those of you in Zoom, he asked, can we post the slides before the lecture? I'll do that. I'll make sure to keep that in mind next time. Yeah. Security services. So now we're in the AWS security services realm where we're actually implementing security measures. So let's get into it. In terms of web security, right? You want to have two different things. You want to be able to secure your web against exploits and attacks, and you also want to secure your website or application against network issues. So we have AWS WAF, which stands for Web Application Firewall. So this application security layer is just a way to prevent web exploits and attacks in things such as HTTPS requests or API calls or things like that where your data is vulnerable. Web Application Firewall is just a layer on top of that that kind of prevents that from happening. And it prevents common web exploits. And then that's kind of like, as I previously mentioned, just protecting the data layer. And you don't want any data to leak. And AWS Shield is kind of the network layer, right? So this includes things like DDoS or DDoS protection. That's when your servers get overloaded with a lot of traffic. And they have tiers for that. You have a standard tier, and then you have an advanced tier, which handles a lot of DDoS traffic. I don't know if you guys have played games in the past, or like, I don't know, maybe in like League of Legends or Modern Warfare, things like that. A lot of people like to threaten you with DDoS attacks if you're beating them really badly. This is like an example of that. You can defend against that with AWS Shield. So it's pretty cool. And then there's also another service called AWS Trusted Advisors. So this is like a more easy one that's automatically implemented when you're signed up for an AWS account. This keeps track of basic things. So let me get into that. It keeps track of your optimization. So it'll automatically detect where costs are being a little bit not as efficient as they could be. So it detects those things. So a lot of your infrastructure, if you're using services that aren't really needed, it'll let you know of those services that they need to be like discontinued or upgraded. And then it also improves security practices. It reduces costs with that cost optimization. And it also gives you reports on a lot of your quotas and your billing and information such as that. And this is kind of works on everything within your AWS account. So you're able to see everything from the top to bottom of your application, for example. And let me get into more in depth about what these cost optimization things actually mean. But AWS Trusted Advisor has 7 main components to it that it runs checks on. So it does 7 things. The first one being the Amazon S3 bucket permissions check. So this basically is automatically done. You don't have to worry about AWS Trusted Advisor doing anything where you need to do anything for it. It'll automatically run these checks for you. But the S3 buckets permission security check is just checking to see if all your Amazon S3 buckets have their privacies set to private, or making sure that they're not open access so anybody can come in and change your data within the AWS buckets. So in your portal, in the AWS Trusted Advisor, if you have Amazon S3 buckets that are open to the public, it'll have a notification saying you need to check that and make sure that's private, because you don't want your information getting out in the buckets. Security groups. So when you're doing EC2 work, so when you're creating virtual computers and running software in these virtual settings, you want to make sure that your ports, we'll get into ports later, but you want to make sure your ports are restricted. So you don't want anybody accessing your ports and getting vulnerable information from your software and programs. So there's a security groups check that makes sure that everything in your EC2 instance is secure in that sense. And that's more on the port side. There's an IAM use check, which is like, you need to make sure that you're not the only one using the root user account, meaning you have to have multiple users in order for it to be compliant. Like we previously talked about, we don't want to do everything in the root user account because that's like the end all be all. If you delete something, you can't recover it. That's why we always want to create an IAM user for ourselves and then log into that IAM user to do things. We don't want to do anything in the root account. And this just detects whether or not there are more than one account other than the root account. And then another one, the fourth check is it detects whether you have multiple factor authorization on the root account. So this just checks, are you double layered secured? So in case anybody tries to log in, it'll let you know and you can kind of approve and deny. That just makes sure that when you have access to the root account, that you're the one that needs to do that. And then there's something called EBS. So this is Elastic Block Service. It does an Elastic Block Service public snapshot check. So EBS is like a storage service, but it's like about blocks. Blocks, you can think of it as like records in like an Excel sheet, for example. So blocks are like bigger pieces of data, different from S3 buckets. But when you have public snapshots, that means that you're taking your current state of that storage and you're just copying the data, right? And then if you want to transfer that data over to certain people to like hold it into record or like put it into history, you don't want anybody that's not supposed to be seeing that data to see it. This is a check that detects whether or not your data is secure and that it's not open access. And it's the same for the sixth check, RDS, Relational Database Service. It's just another essentially storage. You don't want your data to be seen by anybody. So it just detects if your public snapshots are restricted to only people within your organization. And then last but not least, service limits. When you're using like max capacity on your EC2 instances or your CPUs being overloaded, it'll let you know of that and you can kind of upgrade accordingly. Yeah, I went kind of fast, but does anybody have any questions about any of those 7 checks? Cool. So another service that we're going to be talking about is Amazon Inspector. This is a critical one when you're using Amazon EC2. So it's basically like an agent installed within the EC2 instance that kind of detects whether permissions within EC2 are not at best practice. What I mean by that is, let's say you had an EC2 instance and you created permissions that allowed anybody to access the EC2 instance, Amazon Inspector would be something that detects that and lets you know, hey, you need to block off this access and restrict it so only people within your organization can use it. And when it does these checks, as you can see by the picture, it organizes it by severity. So for example, if you have like a process that exposes data, it'll let you know it's high priority, and then it'll let you know an assessment, which is like a guidebook to what you should do. So this is like a compiled list of here's the problem, here's how severe the problem is, and here's the solution. And here's some examples. So if you can access EC2 from the internet, or like the root login is enabled, since you don't want to be logging in from the root account only, it'll detect that and list that as high priority. And it also detects if you have outdated or vulnerable softwares. So it'll show up on this as well. Next, we have Amazon CloudTrail. So this one is a little bit easier to understand. CloudTrail is just checking all the user history and all the API calls that are performed within your organization. So this is like, I guess you can see it from a God perspective. You can see everybody's activity within your organization, all the IAM user activity, and you can see what API calls are performed within the organization. So this is just like, it gives you a summary and you can kind of see what everybody's up to within the AWS environment that you've created. So that's CloudTrail. That one's pretty simple to remember. And then we have Amazon CloudWatch. This isn't actually security related. This is related to the resources themselves. So I'll differentiate between these two in a bit, but CloudWatch is essentially a service that monitors the health and the performance of your services, like your other services. For example, your S3 buckets, your EC2 instances, Amazon Relational Database Service. CloudWatch oversees all that and lets you know how they're performing, where you need to upgrade, and where you need to slow down on utilization. So you can think of CloudTrail as looking at the users and CloudWatch as looking at the resources / services. And then another one, there's a lot. I'll go back and summarize, but AWS config. So I'm gonna scroll back. CloudTrail, you get the history of users, right? What they've done. Config is like what we're gonna do about it. So let's say a user created an Amazon S3 bucket, but they set the permissions to open access, meaning everybody can access it. AWS config notifies you that that's bad practice, that's not good, and that you need to do something about it. And you can set rules. So if in the case that you want your Amazon S3 bucket to be open access, you can set rules for that. But in the most case, you can set other rules to kind of prevent that from happening, and it'll send you a notification. So yeah, I'm gonna describe the relationship. So config is the effect. If you want to think about CloudTrail as being the cause, config is like the effect. CloudTrail is what has happened, and CloudTrail is what has changed and what needs to be done. So as you can see here, it's focused on how your resources have changed. And then AWS, yes, 1 second. I'm gonna scroll back. Yes.
Okay, so for that CloudWatch thing, what's the difference between CloudWatch and the thing that performs like the 74 checks?
Oh yeah, perfect. Good question actually, because I was confused about this when I first learned this. CloudWatch is more on utilization and performance, while Trusted Advisor is more surrounding the basic components such as cost optimization and security. So there's different categories within Trusted Advisor that it specializes in, whereas CloudWatch does a general overview and just focuses on performance and utilization. So in CloudWatch, there's nothing like cost optimization or things like that. And then next is AWS, not kill myself, but AWS KMS. It stands for Key Management Service. So you know how if you create like a database, right, and you have sensitive information in there, you want to kind of encrypt that if you're building a large scale application. Like if you had individuals' social security numbers or phone numbers or anything along the lines of that, and you're using a database, you want to be able to encrypt that information. AWS KMS is a way to generate keys for cryptographic encryptions. So you store them in AWS KMS, and they're stored within AWS's physical hardware. But you, as the customer of AWS, when you're using AWS KMS, you just have access to the keys. So let me reiterate. AWS KMS is having the access and management of all your cryptographic keys to encrypt important data, and they're all stored in one location. But you as a user, you have access to the keys, and you don't have to worry about any of the physical hardware. And there's an important distinguish between KMS and Amazon HMS, Cloud HMS, or HSM. HSM stands for hardware. I can't remember the acronym off the top of my head, but I'll come back to that. This is essentially KMS, but a little bit more involved. Well, what I mean by this is in AWS KMS, you're storing all your keys in one place in hardware at Amazon data centers. Cloud HSM makes sure that all those keys are distributed across multiple hardware services. So let's say one hardware service breaks down. You don't want to lose all your keys, right? But if you store them using KMS, all your keys would be gone. But Cloud HSM just distributes that management of keys. And you have to kind of pay a little bit more for that because it's just another layer of protection and recovery. Next, we have AWS Parameter Store and AWS Secrets Manager. So when you have a lot of sensitive information, like someone's login information for their IAM user account, or you have like access codes to databases, you want to store that all in one location. So you use something called AWS System Manager Parameter Store. And this is where all that lives. You have access to all your login information and those strings that you use to connect to databases. That's all stored here. And you can do things like set time limits on how long those keys and passwords last. And then you have up to 10,000 parameters for your free tier. That's important because when you're building large scale applications, right, you want to constantly make sure that your keys are all in the right place. So when you know what's going on, you can kind of prepare in case account information or connection strings are lost. And then Secrets Manager is an automated version of that. So typically a business practice that a lot of IT organizations use in large scale corporations, they like to have you create new login information every year or so, or change your password every year or so. If you've ever worked at an internship, if you worked at it long enough, they ask you to change your login information every once in a while. This is essentially an automated version of doing so. So it takes your current login information or keys or access to databases, and it randomizes it. So it creates new ones, right? And then it distributes it to all the users again. And it's automatic, so you don't have to worry about doing any of it. So it's essentially another layer on top of the Systems Manager Parameter Store. And it's more secure, right? Because you don't want to have the same login information laying around and then someone else comes across it and logs in a year later. You want to constantly keep that on rotation. And then we have AWS GuardDuty. So all these kind of have overlapping characteristics in a sense. Some are more specialized, but AWS GuardDuty is much like CloudTrail, where you see all your user activity, but GuardDuty actually uses machine learning algorithms to detect whether somebody's doing something weird within your organization. So it's like a sabotage detection system. It detects whether an individual has a lot of patterns of doing things that aren't healthy for your AWS services, like changing certain permissions. For example, that's one. So GuardDuty essentially protects you and your organization from people within that might be up to no good. And there's actually a 30-day free trial in the free tier, and then it gets charged afterwards and is integrated within AWS. And so some more information about this, it charges by gigabyte per month for VPC flow logs and DNS logs, which we'll get into later. And it also charges by millions of events in the CloudTrail. So if you have like 1 million events that have happened with your users, it'll charge by that amount because it's scanning through every single event and detecting which ones are kind of weird. Last but not least, AWS Control Tower. So in businesses that are deployed to the cloud, when you're building an application and you want to be QAing and testing and things like that, you want to have different environments. So a lot of companies, like I'll name one, for example, like Facebook, right? Let's say they're trying to develop a new feature on their app. They need to do that they need to test and be able to test out the QA for that new feature before deploying it to the real world. So that's where a lot of people deploy different environments. Companies have different developing environments and different live environments. So what you see on Facebook right now is the live environment, but they might be working on something inside in the development environment that you haven't seen yet, but you will once they push it to live. AWS Control Tower is just a way for you to manage all those environments. So you can have a development environment and you can have a live environment, and AWS Control Tower lets you effectively see what's going on between those environments, within the environments, and also the activity. And it's actually free. So if you wanted to set up different environments for your projects, for example, and you want to do some testing in one environment, you can do that. So it's a pretty cool service. Then I always forget about this one because of the ugly logo. I don't know, it's like if Meta wanted to turn into mountains or something, but this is called Amazon Macie. This is a more of like the machine learning type of detection of risks, but this is specialized in S3. So when you're trying to be compliant, right, and you don't want data leaks for your applications, Amazon Macie is an effective machine learning tool that makes sure people's SSNs or credit card information does not get leaked. And it's automated because it's using machine learning algorithms. And you can kind of see how there's overlap between the previous services, right? Because we do have a lot of other services that already detect those things. Amazon Macie is specialized in that. And that's really important when you're trying to create a secure website, for example. Alrighty, and I believe, okay, let me clarify the common confusions and then I'll open up for some questions. So AWS WAF versus Shield. So WAF, remember, it was talking more about your data, right? And Shield is about the network. So you don't want to be subject to DDoS attacks. That's Shield. And then WAF is like, you don't want people to access sensitive information. Inspector versus Trusted Advisor versus CloudTrail versus Config. Let's go through that. So Inspector was the one where you deploy it within your EC2 instances, and that detects when your rules are violated, or it sets priority to things that were not best practice, right? It detects high priority problems, it offers solutions, but that's only in EC2. So that's Amazon Inspector. Trusted Advisor is the one that goes through all 7 of the core checks and gives you notifications on whether some of these core checks are not met. So that's Trusted Advisor. CloudTrail, your history, your user history. So that's things like logging in, editing code, pushing to live, things like that. That's all detected by CloudTrail. And Config is the effect of that. Which activities do you not want to happen And if they do happen, it'll notify you. So that's the effect. CloudTrail versus CloudWatch. Remember, CloudTrail is talking about the users. We focus solely on the users, where CloudWatch is on the resources. We want to check the performance of the resources. And then KMS versus HSM. KMS is storing all the cryptographic keys and information within one place in hardware. HSM is doing the same thing, but distributing all those keys across hardware. So in case one server for that hosts your keys goes down, at least you have other ones that you made sure are not deleted. Secrets Manager versus Parameter Store. Secrets Manager, that's where you store passwords, login information, and database connection codes. And Parameter Store, sorry, this is actually the inverse, excuse me. Parameter Store is where you store login information, access codes, things like that. Secrets Manager is the automation of that and having the ability to randomize things and create new ones, new parameters to distribute to your users. Alrighty, that was a lot and I went kind of fast, so I'm gonna work on my pacing a little bit, but does anybody have any questions? Hopefully that's a good sign, but let me know if I can clarify on things because I feel like some areas I was a little quick, but okay. Break. Cool. We'll take a quick 5-minute break and I can kind of relapse on what I've talked about and kind of clarify on some things. But yeah, we'll take 5 minutes and I'll set a timer. But yeah, feel free to chill out. Let me check to see if Katan is in the Zoom. Okay, he is not. Cool. Yeah, for the most part, these services I'm talking about, you won't necessarily be implementing them in your projects for the final project or like in your labs, but they're just good information to know for the industry because a lot of them use these protocols. But for the most part, if you don't remember everything here, that's fine. We will quiz on it, but you can always reference the slides. Yeah, but no pressure if things are confusing because when I learned this as well, it was all over the place and there's like so much overlap and so many different buzzwords, but yeah. And feel free to ask me any questions in the meantime if you need clarification. Yeah, go ahead. Yeah, let me think of an example. So, for the application to the decal, I always like to use the S3 example because it's like a really simple service, but let's say let's say you have like an Amazon S3 bucket that you uploaded like really important information to, such as like credit card information. And you have permissions that you can set on those buckets and how they're able to be accessed when you're integrating with like EC2 or other services. You want to make sure that it's not open source, right? So for example, the Amazon Macy, it'll use machine learning, kind of look at the picture, things like that, and it'll detect that this is sensitive information. Like, hey, we need to make sure this does not get accessed through web exploits or things like that. And that's when a service like Amazon Macy would let you know, like, hey, you need to change the permissions on this. That's an example, but good question. Yeah. I've never actually implemented any of these services in my projects. So that just shows like it's more of like a higher level concept that you kind of do once you get to like bigger groups and work in like a really strong cloud infrastructure. But whoops. Can you guys tell I'm nervous? I'm like shaking. Yeah. Yeah. It'll get better as the weeks go on. It's my first time, and it's like I gotta get all the nervousness out. You guys gotta hear me quiver a little bit, but bear with me. I'm gonna learn while you guys are learning too. So alrighty, let's get back to it. Hopefully that gave enough time for everybody to at least digest a little bit. Alrighty, next topic. We're gonna be talking about support. So when you're building your projects or you're running a business in the cloud, you want to be able to have people to help you out that you want to contact frequently, or for example, something happens and you need urgent help, there's support for that. So we'll go over the different tiers of support. So in AWS, you have different tiers of support. You have basic, that's when you're just trying to do this for like a class project, like you have a research project or you need a project to implement something. That's basic support. You don't have to pay anything for that. Developer, that's when you're more upscale and you're creating like a project that's a little bit bigger than what you would normally do for a class, or like you have a cool idea you want to implement. That's developer. Business is when you actually have a business going on, you built an application and you need some infrastructure and support. That's a business tier. And then enterprise, that's when you're like a complete corporation or a company and you're running on Amazon Web Services. That's enterprise. And let me get into the details. But yeah, AWS support, when you sign up, you already have access to this. One of the coolest features is that you have access to AWS Trusted Advisor, which I had mentioned earlier. You have access to all those 7 core checks. So now when you're doing these projects, you have those 7 core checks to keep you in line. You have technical support. So you have access to forums, papers, and you can email at any time and they'll get to you. And then you also have a personal health dashboard. People get this confused with CloudWatch, and I did too. It's a little different because it detects the health of your services. So let me provide an example. Let's say you're using an EC2 instance to perform like a function and it gets really overworked. It'll detect that and it'll also alert you and let you know what's impacting it. So you know how CloudWatch just lets you know what the performance is. Like let's say you're at 80% capacity of CPU usage. CloudWatch lets you know that you're at that, but personal health lets you know what's impacting that. So it's a little bit more in depth, but that's AWS support basic, and the pricing is free. We have developer. So oh my God, that crap. AWS developer. This is when you're, like I said, you're working on more experimental projects or bigger projects than like what you do in class. You have the trusted advisor, and then you have a bit more responsiveness from technical support. So that's kind of the layer on top of basic that you get with this tier. You get business hour email access to a lot of specialists in the cloud team. You have the ability to have one primary contact in your organization, one that coordinates with those specialists. You can open up many cases. So that's just like emailing, hey, I don't know how to set rules or permissions to integrate this, or to how do you use like Amazon EC2, for example. You can make case for that and usually get responses within 24 hours. And if you have like a really important project or something and you need something fixed, they would respond in 12 hours. And the pricing is pretty nice, but it's $29 per month or 3% of monthly AWS usage. The second one is kind of confusing to think about, but $29 a month, that's like gas and electricity if you're paying rent. Like, so it's quite a bit for help that you really need. But when you're experimenting, there's always the internet, but this is an option. AWS Business, this is when you have like a full-scale business going on. You have AWS Trusted Advisor as well, and then you also have technical support. So this is cloud support engineers. So these are people that have actually built applications in AWS and they're versed in them, whereas cloud support associates, they just know about AWS and what the services are. So they just kind of tell you what you can find in forums and things like that, but support engineers actually know implementation. So you have the ability to chat with them. You have unlimited cases and anybody within your organization can contact them. And yeah, same responsive times for general guidance and when your system is facing some issues. But since you are a business and if you're trying to generate revenue, right, you want to keep that system up and going so you don't lose out on profits. When your production system goes down, you have faster responsive times. So you have 1 hour for when like your servers or something shuts down completely. And then when something's going on within your code or you can't fix a bug or things like that, and it's really impacting your business, you have responses in less than 4 hours. And then this is actually a lot more expensive. It's $100 per month, which is pretty reasonable if you're creating a good stream of income through cloud. And then boom, enterprise. This is, I'm gonna cover, I can't cover it, but yeah, you're gonna be paying upwards of $15,000 per month to get this support. But this is what it does basically. You have an enterprise, you have a big corporation, right? You need to make sure everything is working and everything is perfect. You have faster response times, like very fast. Within 15 minutes, you have someone replying to you, letting you know, hey, this is what you need to do. And then you also have something called a TAM. So a technical account manager. They're basically someone that's dedicated to your organization and they only specialize in your, I guess, applications. So you can think of it as you're hiring an AWS specialist to work for you, but they're still working for AWS. So it's like they're an advisor and they're looking after your stuff, but they're just working for them. But they're still doing the same functions as if you hired your own. But that's kind of the difference. So you can see why it's very costly because you're almost paying for their salary. And then I can't say this. Okay, penetration testing, pause. Just kidding. AKA pen testing. This is like where you can simulate attacks on your system so you can see vulnerabilities or like areas where you can improve upon. You can't do DDoS attack simulations without approval because it's like a networking thing. But yeah, penetration testing or pen testing is just a way to see if your infrastructure is strong and there's no leaks or things like that where web exploits can happen. And you can do that on a lot of these services without approval. But like if you wanted to test how well your service or your servers would run against like high traffic, you would need to contact security teams to have them approve that. But yeah, penetration testing, a way to test your product against real world scenarios where someone's trying to exploit you. Questions? Alrighty. Networking basics and binary. This is okay. Someone lost their phone. Excuse me. Okay, someone lost their phone from like a previous class or something. Sorry for the interruption, but we'll hope that doesn't ring again. But networking basics. So we're going to be talking now about networks. And this is a shift from what we were talking about with security services in the cloud. This is going to be the more general topic of networks and IPs and subnets and domains. Like, what is all that? This is like a little overview, so you don't really have to take like an in-depth online internet web course about it. But yeah, binary, you'll talk about this if you're taking 61C. It's just a way to represent numbers in twos, essentially. So you're not talking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You're going 0, 1. Those are the only two values in the binary system. So yeah, a byte, you hear this a lot. A byte is 8 bits. So that means 8 digits in the binary system. And remember, a digit can only be 0 or 1 in the binary system. So what does that mean? Like, how do we kind of translate that? How do we go from one binary to decimal, vice versa? Yeah, so a binary number can have 2 to the n value. So when you think about like a byte, which is 8 digits long, right? And if each digit can only have 2 possible values, 0 and 1, the combination, how many possible combinations of 8 digits in binary you can have, it's 2 to the n, right? Because you have 2 possibilities per digit and you have n digits. And some cases it's 8 digits in 1 byte. But yeah, so that's a lot of numbers for 2 to the n numbers for such a small representation. 8 digits, you can get up to, 8 digits, that's 256. Yes, 256 different values. So yeah, you don't have to worry too much about converting between those or going back and forth, but just remember that fact that you have different possibilities for such a small length of digits. It's very confusing, but hopefully that made sense. All right, IP and ports. The reason why we talked about binary is because IP addresses are represented in binary, but we see them as decimals. So more on that. So IP addresses, what are IP addresses and why are they used and how do you even read them? So IP addresses, they're just ways to give a sense of location in the networking world. So, in like real world, you have addresses to represent a house or where you are. IPs are ways to represent areas in the network, in the entire global scale. So today we use something called Internet Protocol version 4, IPv4. And basically every section of the planet has an IP. So when we use IPv4, which has 4 bytes, so that's around 4 million different areas that we can describe through IP addresses. But we represent that we split that into 4 bytes, so it looks like this. So I have 0, 0, 0, all the way up to 25, 25, etc. So yeah, this is like the translation between binary to decimal possibilities. So every area in the world has one value that falls within the range of 0, 0, 0 to 255, etc. And a port is something that follows the IP address the 4 numbers with the 4 periods. A port is a way to go into the IP address and kind of distinguish like specific parts of what you're trying to access. So let me explain that. Like if you have a device that has an IP address, like your phone, for example, certain transactions such as receiving emails or accessing web pages, they use different ports because they're sending different things of information across the network. So that's what a port is. It's like the specific function of the device you're trying to connect to, they have their own unique port. So yeah, it differentiates traffic and transactions. So let's say your phone has an IP address. You have certain ports within that phone. So you have certain things that follow the IP address. So what I mean by that is you have a colon and then you have numbers following it that represent the individual ports. So yeah, this is the IP address, for example, your device. And then for a function like email, it would go to this address. And then that's the connection between those two. And then like a firewall is, you hear about this in like class and everything, but a firewall is just a way to block certain connections to certain ports. So you could have a firewall, you can create a firewall that just blocks receiving emails like for everything. So like if you can design a program that blocks access to your email port, and yeah, you would just never receive any emails because it blocks the specific connection to this address, for example. Does that kind of make sense? Anybody need any more clarification? And this is like kind of a map meme of like dividing up the internet. But yeah, we'll touch upon that a little bit more. But subnets and CIDR notation. So to add on, so when you have a network, right, you have a lot of IP address that represents different areas of the world. You also need to represent different areas within those areas. So it's like a sub area or a subnet. You have, let's say you have an area that is represented by an IP address, but you want to get the specific sub areas within that. You use a subnet, and that's represented usually through a CIDR notation or CIDR notation. It's a little bit confusing. I wish I could draw it out, but basically, when you use CIDR notation, you have this slash and then a number following the IP address. You don't have to worry about the specifics, but that slash and the number differentiates the sub network and the main network. So for example, these numbers right here, 198.51.100, that's your IP address. And then the numbers 0 to 255, those are all part of the subnet. So you can have essentially 256 different individual sub areas within your larger IP address. So when I mean sub areas, a lot of devices, right, they connect to an individual address within the subnet. So you can have a device, you can have, in this example, you could have 255 or more, or 255 or less devices connected to an IP address, where the IP address are the numbers preceding this final period. Yeah, and CIDR notation is just kind of the standard to see how big of an area or subnet we're talking about. So if I had slash like 16, for example, the entire actual IP address will be a lot shorter, and then you have more possibilities of subnet IPs, if that makes sense. So yeah, it's different for larger networks in sub IP, but I can clarify that, but you don't have to worry too much about that. And cool. Networking basics. So you have a domain name system. So DNS, you hear about this a lot, and you're always typing in your browser, right? You're sending HTTPS requests to certain things. A domain name system is like a translation of an IP address to a readable form in English, for example. So Google, for example, has 128.200.192.202. That's their primary IP address. But in the domain name system, it's represented as www.google.com. So yeah, when you're actually connecting to Google, you're actually going and accessing their servers at this IP address. So this system, you can register many IPs to a domain. So you're not always connecting to this IP address, for example, because Google has many servers. So what I mean by that is a big corporation like Google, they want to have a lot of servers across the world. So when people connect to it, they have fast responses and good latency. So they might have multiple IP addresses associated with their domain name. So it's like a way to distribute, it's a way to categorize all the IP addresses that you own. So one person, when they're typing into their browser, they don't have to worry about connecting to which specific IP address. They can just type in Google and it'll connect to one of the servers associated with an IP address. And a lot of times when you're getting a lot of traffic, like let's say I'm Google and I'm getting a lot of users trying to connect to one IP address, there's ways that you can distribute that incoming traffic to other servers. And that's called load balancing, which we'll get into. Is any place, do I need any clarifications on some of the stuff I talked about for now? Cool. All right. Yes. I'm not actually sure. I don't think so, right? Because when you have, well, this is my rationale, but if you have multiple domains to the same IP address, that means you could type two. That's a good question. You know, I'll actually get back to you on that. I wish Katan was here. I could phone a friend, but yeah, cool. Yeah, I'll reach out afterwards. But internet versus private networking versus NAT. So your internet, right? You have a lot of public IPs that you can access, but you have to pay for them. So like Google's IP address, that's all paid for. But AWS has this thing where you can do this. I'll get into the service later, but you can actually get a public IP address so someone can access your servers for your application. And yeah, there's a service in AWS for that. But yeah, the internet has a lot of public IPs, but you need to pay for them. But like, let's say you have an IP address, right? You have an IP address at home, but you didn't necessarily pay for it, right? It's your IP address. That's actually not true. You actually bought the IP address from your internet service provider and they gave it to you. So when you think about it, like let's say you have DirecTV or AT&T and you have like a router, you actually bought an IP through them. And then they just provided you with the IP address and the sub networks. So when devices connect to your Wi-Fi, they can connect to your IP. But that's usually a set of private networks within a public IP. So when you buy it from your internet service provider, you have one main public IP that you communicate and people can communicate with you. But you have private IPs or sub networks within that public IP that only interact with each other. So your devices connecting to other devices when you're within your IP, they communicate through private IPs. And that's a way we've mitigated the problem of having to worry about buying public IPs. You do it through your internet service provider. And then the router is essentially the way, a tool that kind of directs communication within your subnet. That's what a router does, essentially. It just directs traffic of transactions and communicates with the global versus local scale. And then networking basics, you got web apps. So a lot of buzzwords, front end, back end, and full stack. These are things you're gonna be learning a lot if you wanna be a full stack developer. When you're building a web applications, there's essentially 3 layers. You have something called the front end, you have a back end, and then you have the database layer. So let me get more into detail. The front end is like the visual, right? When you go to google.com, you see that search engine, right? That's all visual. That is represented through coding in HTML, JavaScript, and CSS. So this is like, you can always think of it as the design and visual / user experience. That's why UI UX is associated with front end. It's all what you see and how you interact. That's front end. Back end is how interactions turn into processes. So let's say you click search on something you typed into Google. The back end takes what you put in and then does something with it. In this case, it returns what you wanted to search. That's back end. Back end is like the behind the scenes, doing all the work kind of thing, the behind the curtains. Front end is design, what you see. Back end is what you don't see. And that's usually done in a lot of programming languages, Java, C, Ruby on Rails, etc. Wait, don't quote me on that. I think I mixed up, but yes, Python, Java, etc. And then full stack is when you're specialized in full stack development, you're good and versed in front end and back end, and you know the bridge between those two. So you know how to design UI UX systems, and you also know how to implement what goes on behind those systems. So full stack engineers, they get paid a lot of money, front end, a lot of money, back end, a lot of money. So there's always specializations you can choose within web development, and then full stack is just a combination of front end and back end. And then it's pretty different per team, but a majority of the time, when you're full stack, you kind of lean in on both sides of the development. And then like a front end only site. So when you guys created your S3 buckets in the club application, decal application, that's something that's called a static site, because you can access the picture, right, that you posted, but you can't do anything with it. You can just see it. That's something that is a static site, and that's front end only, because you didn't write any code. When you click on the picture, you're not gonna get any response back, right? So that's cool. You guys are already front end engineers by doing that. And then yeah, for presentation is the front end. Like I said, everything you see, application, all the functions and all the hard work that happens in the back end. And then data is data is the layer where you have the databases, and that's where your back end functions kind of connect between the front end and back end, or front end and database. So I'll get more into that, but yeah, typically in a web application, if you have a lot of data, like let's say you're building an Instagram clone or like a social media app, user data is stored in databases. When you click follow, you hit the button, that's front end. Back end, you're connecting your user account with their user account, and that's accessing user information in the database. So there's that whole bridge between all three architecture tiers. So yeah, that's full stack development and web applications. And then HTTP requests. So you do this every day. It's just how you access resources over the web. When you type into your browser, you're performing some kind of function to get something from a server. So what I mean by that is, let's say you submitted a Google form, right, for attendance. You're actually performing HTTP requests, and you're doing something called posting. So I'll get into this, but get is receiving information or resources or objects from a server. Posting is giving them some kind of information or object. And then putting is updating, and deleting is deleting. So in this analogy with the Google form, if you were to submit a Google form, you're sending an HTTPS get request, or sorry, post request, and you're submitting a form, right? You're creating a response, you're creating a new database entry. If you put, that means you're editing your response. So like, let's say you want to edit your Google response, that's put. So you're updating the database entry in that server. Delete, let's say, you can't do this with Google's form submissions, but if you wanted to delete your attendance form submission. That's what delete does. And then get is like when you're just trying to access it. So those are the different kind of functions, but you do this every day. And yeah, it's cool underlying layer. Yes. The requests are done with the server side. Yeah, so good question. So he asked, how are the requests processed on the server side? That's a good question. Let me think about that for a brief second. Yeah, I'm pretty sure when an application gets a HTTPS request, they process it through their servers. Like HTTPS are kind of connected to like networking because you're processing that information through your servers. And then you have integrations within your application that takes what you have from your network and turns that into what you want to do with that information. So for example, if I submit a Google form, Google has servers that process that incoming traffic, identifies that that's a get or post request, and then it'll translate that into a response within the server and the backend. So hopefully that clarified, but. And then networking basics, another thing on top of that is APIs. You're going to be probably used to a lot of APIs by the time you're in the industry or have some familiarity with it. It's basically an acronym for application programmatic interface. So if you want to think about it in a broad sense, because this is kind of an interesting topic and kind of hard to conceptualize, it's a way of getting information without having to understand how you got the information. So it abstracts like the implementation of getting information from something. So for example, let's say I built like a weather app and I want to get weather data. I want to get weather data from like a website that has weather data displayed on their thing, on their database, or like you can see it. You can perform an API call, which is essentially grabbing that weather data and displaying it in your program. And you actually don't know how that data got processed to you or how it got grabbed from their database and sent over. You just kind of have to perform the call and trust that it'll do the rest. So another analogy is like you sit down at a restaurant, right? You see a whole menu, you see a whole API, right? And let's say you want to order a hamburger. The chef is like the other side of it. The chef will process your order or your API call, and they'll make the burger for you. You don't know how the burger is made, but you get the burger. That's what an API call and API kind of abstracts and does for you. You don't want to worry about how you got the information. You just want to worry about the information itself. So when you get that burger, you don't care about how it's made. You just want to eat it. That's what an API call is, basically in a hamburger sense. And yeah, the APIs are built to also handle HTTP requests. That's also done in the backend. And another thing to add on to that, the reason why API calls are important is because some things, some data you don't want to expose to the public. The only way you can access your information on someone's, excuse me, let me rephrase that. You don't want to have your information on your servers be open to the public. You only want people to access that information privately, and that's done through an API call. So someone sends an API call to me, I'll give you your information privately, and no one else would ever know. And usually there's API keys for things like that. So there's authentication. So when you grab APIs, they know it's you and you're not someone else that doesn't need that information. Any questions about that or anything I could clarify on? Awesome. Okay, so Amazon VPC. This is a bit of like kind of the private cloud structure I was talking about in the Zoom lecture. But virtual cloud network or Amazon VPC is where you can launch resources and you can connect to private servers. So what I mean by that is, let's say you have a hardware you have a database, right? Physical database that you have somewhere and you want to access it, you can do that through a virtual cloud network by providing it an IP address, and then you also being able to access that IP address privately. So that way, no one can access the database except you yourself, because it's a private connection between you and the database. And it has several use cases, but it's like a private cloud sharing model. And then standard stuff, you have different amounts of subnets you can have. And using CIDR notation, it gives you the possibilities of how many different devices or centers you can have within that subnet. And then they have an internet, so public subnets, this is something I want to touch upon. Public subnets, they have access to the internet, right? So when you want your data to be accessed across the world, you do that through public IPs or subnets. But if you want things only to be interacting between you and that private database, that's done through private subnets. And that's done through a NAT gateway. So no one else has access to that but yourself. And VPC is just the way to handle all of that and orchestrate it. And then now we have Elastic Load Balancer. A lot of services I'm keep adding on, but ELB is a little bit more simple. Remember how I said Google has to distribute all that traffic somehow, right? Well, ELB is the solution for that in the cloud. If you have different availability zones, or if you have different subnets within different availability zones, you can use ELB to kind of take in incoming traffic that's high in one availability zone and distribute it to another. So, for example, if you have a lot of people trying to access your website, it's getting overflowed, you can distribute a lot of that traffic to another availability zone and have everything be up and running. And ELB does that automatically for you. And so there's actually two different types of load balancers that we want to focus on. How are different types of dividing up the traffic and things like that. We want to talk about application load balancer and network load balancer. So application load balancer is when you have traffic such as you're trying to pay for something through a website versus you're just trying to access that website. Those are two different types of traffic. So you can use an application load balancer to distinguish that traffic and to send them to their own respective zones. So that's kind of focusing more on the type of traffic. And then we want to focus on network load balancer, which is focusing on the general traffic. So if you have a lot of connected users to your website, you can use network load balancer to split up those user connections. Whereas application load balancer, you separate the individual requests of those users. So it's like load balancer in the application sense is taking different types of traffic and separating it, and network load balancer is just taking all the traffic and separating it. And like a good example is for network load balancer, like Club Penguin, for example. I don't know if you remember, but when you log on and you have different servers, right? And it says, oh, capacity of 26 or something. That means like only 26 penguins or people can connect to that server. That's an example of network load balancing. It's distributing and making sure that the server can handle only a certain amount of people. So in the case of Club Penguin, if Club Penguin was in the cloud, you have different servers, and network load balancer would split all the users into those different servers. And then gateway load balancer and classic load balancer, we won't talk about those or get into that because those are a little bit complicated and complex, and we don't really tend to use them with our expertise, but they're there, and those are some options outside of ALB and NLB that are within ELB. Nice. And then, so a little bit about pricing. This one took me a while to understand when I first learned it because it just doesn't make sense because you're taking they price it very weird. So there's different traffic amounts that you have to split up, right? The way ELB charges you, it's based on, okay, we have to split up traffic. I'm gonna charge you per hour that I do that. And it also charges you how much traffic you're splitting up within each individual like division. So what I mean by that is like, if I have 10 people, right? And I split it into two sets of 5, and I split it and then put them into their own respective servers. ELB charges you for every hour that it's doing that. And it also charges you on top of that a rate given by the LCU that is how much are we actually splitting up. So if I had an LCU low capacity unit of like 3 and I had 5 people dividing up, like it would charge you per rate. Does that make sense? Wait, let me rephrase that. So you get traffic, you split it up, it charges you per hour of doing that. And then within each subset, if you have a certain amount of connections that are above the capacity or the LCU, it'll charge you for that per hour as well. So it's like 2 layers of charging. And you don't really need to know that too much, but it's just something to know once you get into, if you ever come across an environment within ELB. And then, yeah, you get a free tier in ALB, the application load balancer, where it gives you 750 free hours. So 750 hours of like splitting up traffic, and then 15 LCU. So like, that's like the unit of capacity. So if you go over that capacity, it will charge you for that individual hour. But yeah, CLB, classic load balancer, that's not really something we care about. And you can find more documentation about here. And if that's not clear to you, how I explained it, I think AWS might offer some insight as well. And then, yeah, CloudWatch metrics actually work on ELB. So it demonstrates and shows you all the active connections you have. And it'll show you how much of your capacity that you used up, the LCU units you used up. And it'll show you how much you're going over and things like that, a lot of metrics. It'll track how much HTTPS requests you're getting. And then there's a lot of other individual statistics about that as well. So you can kind of see some graphs, the zones, and then like types of connections, new users, active users, other transactions. And it'll put it into a nice thing. So this is a real application of CloudWatch. You can kind of see this as performance, right? Because CloudWatch is based on resource performance. This is all performance metrics. Cool. Route 53. So we talked about domain name systems, or DNS. Route 53 is a way for you to register domain names. So it's like GoDaddy, but in AWS. Let's say you want to create a domain within AWS. You can do that in Route 53. And it also has some underlying effects on how it changes network traffic based on which IPs are associated with that domain. And it performs health checks within Route 53. So you can kind of see if your domain is, if your IPs are suitable and like distributed correctly with integrations to ELB. And then pricing, it depends on your top level domain. So your main domain, like google.com. And it's the pricing changes on whether like the domain is high in request, meaning like if you want a google.com, you can't buy it because Google owns it, right? So it changes the price as well. And then AWS Elastic Beanstalk. This is pretty much the last service we're going to talk about. We've been talking about it a lot, but Elastic Beanstalk is one of the most important services we have in the cloud because it's like an orchestration service, meaning it's going to control a lot of different components within your web application. So it handles like it handles all sorts of code in your EC2 instances, for example. But let me explain this in a better way. Elastic Beanstalk takes all the network phenomena that happens, translates that to certain servers, makes those servers interact with your EC2 instances or your like programs, and it does all of that for you. So you don't have to worry about any of it. It's the orchestration of all that, and it connects everything. So you can actually build a full stack with Elastic Beanstalk as a tool. You can have the EC2 instances, for example, at one layer, an ELB, which is like the network load balancer on top that directs all the traffic, and have RDS, your database, underneath. And then you have Elastic Beanstalk that manages how all that connects. It's a very abstract way to think about it, but that's an overview of Elastic Beanstalk. It's typically used for really, really large applications where you need a lot of management, but for personal projects or such, it's cool to experiment with, but it's very complicated and usually overworked. Like, how do I say it? Like, you don't need to use it. Yeah. And it's zero cost. But yeah, it gives you a default domain name as well. So using that, we can build a 3-tier on AWS, a full stack. So that's pretty cool. We'll get into more details on, if you're interested in doing this, how you would go about it. But these are a lot of the tools you're going to be needed to use to develop some kind of application. And we're at the end of our lecture. Here's the word of the day. You can scan the QR code. And then also if any of you guys have any questions, feel free to let me know. I'm always taking feedback as well. As you can tell, I'm not very confident in my lecture style, so I need to take more time to practice. So any feedback is greatly appreciated. I want to make sure that everybody can understand me as effectively as possible. And I love feedback. So yeah, I'm here to learn with you guys. So cool. Any questions in the chat as well, I can answer. And then, yeah, whenever you're ready, feel free to head out. We ended a little bit early, 30 minutes early, but it'll be nice. No demo today because the services usually need to be integrated when you have a full scale application running. So yeah, thank you guys so much for coming out. I promise next week I'm gonna be practicing a lot so I can present the material in a more concise manner. But thanks guys for bearing with me, and I'm excited for the rest of the semester. Yeah, thanks. Appreciate that. Yeah.
What products are we going to use for the labs or products?
Yeah, so our grading team / reader team, they're actually coming up with some projects right now, labs right now, but for the most part, an idea we had in mind was we're going to be focusing on like a certain service each week, or something you can like really get familiar with the service. That'll be like a lab idea, or it's like an integration of a lot of various services. So like 1 week we might focus on S3 and have you do S3, and we'll give you a guide on that. Or like you might try to test out an EC2 instance, for example. Those are some lab things, but more to come. We haven't really finalized a lot of things. We've been dealing with some logistical things that we want to make sure it gets finalized. But yes. Yeah, thanks guys in the Zoom. Feel free to leave whenever you